What's up, y'all? I'm Tom, and this is Like a Math Class. This is Blanca. This is Like a Math Dog. In this video, what we're going to do is we're going to look at what happens if you're integrating functions in fractions, rational functions, composite rational functions. Let's get to it. All right, so what we're trying to do is we're trying to integrate this function here. Now, it's going to be a little bit tricky because we've got two actual functions here, so it might be a little bit harder to figure out what is the inner function. Well, there's two things that you might want to consider. The first being that if I look at these two functions, this one is a higher power. And I know with my U-Substitution, I've always got some function that I'm going to call U, and then I'm going to take the derivative of that with respect to x. And I know my derivatives always go down in power. So that might be the first thing that I look at is, hey, this one's got a higher power. And so I want to make this thing be my U. So I'm going to make that be 5x squared minus x cubed. So then my derivative of this with respect to x is going to be 10x minus 3x squared. What do you know? Look at that. There it is right there. So now I can multiply both sides by dx, and I'm left with du equaling 10x minus 3x squared with respect to x. Now, I said there's two ways you could look at this. The other way that you might look at this is, if you remember, we had some special case integrals that looked like 1 over x, and when we wanted to integrate this thing, that turned into ln absolute value of x plus c. We can expand this a little bit further to say, well, what if I have the integral of 1 over f of x? Right? So that's kind of what's happening here. And it's not just 1 over that. I mean, you can say 1 over this. If we did, we could say the integral of 1 over 5x squared minus x cubed times 10x minus 3x squared. But I don't necessarily see it that way. I tend to look at it more that once I have my u, that I've got the integral of 1 over u, and then my du is going to be all of this. So I generally don't think of this as a separate thing multiplied out. I usually don't do this piece, and I actually forgot the dx on here because that's just not the way that I work. Now, I do have some students who do like to separate them out into like a numerator multiplied and a fraction multiplied, and that helps them see this a little bit more. So maybe that's a good strategy for you. You know, do what you need to do to make sure you understand that. You don't have to do what I'm doing. You just need to understand what's going on. So after all that's said and done, this thing is ultimately du, or I could say this thing here is ultimately du. Again, either way, it doesn't really matter. But now we've got a nice function that we can integrate. 1 over u, fantastic. That's going to be ln absolute value of u plus c. So we're not talking about u, so we're actually talking about ln of 5x squared minus x cubed plus c, and there is our function. Just like in all of my videos for integration, I like to find the derivative to check my work. So I'm going to take ln of 5x squared minus x cubed. What I have to do is, if I've got this is going to be a chain rule. My derivative says take the derivative of the outside. The derivative of any ln function is 1 over that inside piece. So this is going to become 1 over 5x squared minus x cubed times the derivative of the inside. Well, that's going to be our 10x minus 3x squared. And as we can see, if we move this up into our numerator properly as one fraction, we're going to have 10x minus 3x squared all over 5x squared minus x cubed, and we match our original function right here. So we did a good job. You did good. Well done. We got one more example. I don't know if this one will be easier or if this one will be harder, but either way, if you're finding these videos helpful, make sure you give me a thumbs up, like the video, so it can spread out to more people. We've got a fraction, so I'm going to look at the denominator here. This is the only thing that looks like a function inside here, so I'm going to look at this and I'm going to make that u. So u is going to equal 1 minus 3x. So my derivative of u with respect to x is going to be negative 3. I'm going to multiply both sides by dx, which leaves me with du equaling negative 3 dx. If I want to start substituting my u's in, I'm going to make this the integral of 6 over u, and then I've got to substitute in something for my dx. So again, this is not, I don't have just dx. I don't have a negative 3 up in here. So I've got to get dx by itself. I'm going to move the negative 3 to the other side, and I'm going to have a negative 1/3 du is equal to dx. So now I can put in here times a negative 1/3 du. So I'm going to bring my constant values outside. So I've got 6 over a negative 3, and I'm going to integrate 1 over u du. All right, well, I can do this even before I start integrating. 6 divided by negative 3, that's just negative 2 times the integral of 1 over u du. Again, the integral of 1 over u, that's just ln. So I got negative 2 ln absolute value of u plus c. Well, u is 1 minus 3x. So I've got minus 2 times the integral of ln of 1 minus 3x plus c. Here's our derivative check. So if I've got negative 2 ln of 1 minus 3x, I'm going to take the derivative of the outside. Well, first, this negative 2, that's going to get multiplied along, so we're just going to carry that down. The derivative of ln of x, or ln of any function, is just 1 over that function. That's one of our special rules that's in your formula booklet. So we're going to multiply that by 1 over 1 minus 3x times the derivative of the inside. Well, the derivative of the inside is just going to be times negative 3. So now as we simplify negative 3 times negative 2, there's 6. That's going to be 6 over 1 minus 3x. And we have matched what we have up here in our original problem. I hope those examples were helpful, and I'll see you in the next video where we go through yet more examples on U-substitution. I'll see you there.